Welcome everyone. We'll talk about total quality management, the models and the tools thereof. Now, basically, we'll talk about the tools and the models of total quality management in this presentation. So, primarily speaking, there are 7 tools of QC or quality controls. So, one is a fishbone effect or cause and effect diagrams, as they say so. We will also look into the flowchart as to the what are the processes that needs to be taken into account for one particular from one step to another steps. We are going to ensure checklist. If checklist is the best method of giving a certification for quality control, as in if you have checked all the areas, checked all the processes, checked all the tools. Control charts, another statistical tool wherein which tells us whether the machine, whether the product is within the acceptable limit. Yes, we are supposed to talk about the scatter diagram. Scatter diagram is plotting. We will be showing it in this particular presentation, and the Pareto's analysis, in which it has been stated that the whole groups, including the whole world, whatever aspect that you are going to study around it, is being classified into 80 to 20 ratio. For 80% of the problems can be solved with only 20% of the issues or control points, or vice versa. 20% of the problems consist of 80% of control points. So you need to take the accuracy thereby. We are looking at the histograms as the case might be, as on when on basis. So the cause and effect diagram. Did I say about fishbone diagram? Yes, because it is also known as a fishbone. Now look at it, the pic that I'm showing it to in this particular slide. If you look into it, it resembles a fish bones, right? There is a middle stem which is a thicker bone, almost like a backbone, and then there are other bones associated. Now, basically, what we are like trying to identify quality problem, quality issues, and any one of them can be the source of the quality problems, be it suppliers, be it workers or employees, be it the machine, be it the temperature, the environment, be it the process, the steps that we follow, or the materials, the raw materials that we are utilizing in the production process. So this results into causes and effect. If you can streamline or put everything in orders, everything, let it be the supplier, the workers, the machine, the temperature, the process, or the material per se, you will see you have eliminated the quality issues altogether. So flowchart is again similar to a fishbone diagram, but in this case it might be a complicated steps, primarily utilized in service industry, but definitely for complicated technical problems, technical products that comes around it. These are the issues. Almost resembles like a flowchart. Now, if you are looking it from left side to the right side, but usually flowcharts have been drawn from the top to bottom of a chart of a process, used to document the detailed steps in a process, often the first steps in process re-engineering, as the case might be. Yes, I've already stated about the checklist. It's a basically simply data check-off list, which is designed to identify the types of quality problems at each workstation, per shift, per machine, per operator, and you look into it, what we are finding out. Let's say I'm just giving you an example of a broken zipper. You have found it 3 times, right? Similarly, for ripped material, you again found it 7 times. So every time you're finding, you're giving a tick marks. Similarly, for missing buttons and faded colors. Now, control chart can be plotted. You see, LCL and UCL is basically upper control limit and the lower control limit that comes around it. It is a part of the SPCs or statistical process control, as the case might be. We have to visit the Six Sigma chapters where we need to understand what happens with the quality. There are certain limits, the upper control or the lower control, if we breach, is not at all acceptable. Scattered diagram is a graph that shows how two variables are related to one another. Definitely yes. Data can be used in a regression analysis to establish the equation for relation. Now, if you plot the diagrams on an x and a y axis, you will see there would be a cluttering or a clustering of data points, and that is the point where much of the activities is being coming. But that might be the bottleneck, or that might be the only point where it is going through a funnel. Now, if you can remove those congestions, probably you're taking a good steps towards a quality control. I have already stated about the Pareto's analysis, in which it has been said that the world is divided into not into 50-50 ratio as in black and white or as in day and night, probably into 80-20 ratios. Technique that displays a degree of importance. Look at it, the A category items perhaps has the most amount of values, wherein B, C, D, E, as the number of item increases, probably the value of the item might not be that significant. So if you can control the A materials and the B materials, believe me or not, you have already controlled, taking care of cost control of approximately 70 to 80% of the total inventory. So that is what we are looking into it. Principles of the quality problems are the result of only few problems. Example, 80% of the problem can be caused by 20% of the causes, as the case might be. Yes, we move to the histograms, a chart that shows the frequency distribution of a observed value of variable like service time. Let's say at the bank window, bank drive up windows. Uh, Displays whether the distribution is symmetrical or not so symmetrical, or it is skewed. This is what we will be looking out at the point of saying. Now, what we look out here, product design is a quality functions critical to ensure the product design meets of customer expectation. Useful tools for translating customer specification into the technical requirement, and that is what quality functions is all about. It we are talking about deploying quality. We are talking about meeting the customer expectation. The quality functions deployment encompasses customer requirements. It encompasses competitive evaluation, as in what your competitors are doing it. The product characteristics, as we look into it. Quality functional deployment looks after the relationship matrix. The trade-off matrix, as in we want to buy or we want to purchase or we going to manufacture. Now, that is what is setting the targets, as the case might be. Now, let us look into QFD, or quality function deployment. And if you look into it, we have the customer's requirement, which is all about durability, being lightweight, being friendly, being roomy, being looking nice, being handy. Now, this is what we are supposed to go around it. Whereas the importance has been marked out here, the relative importance have been marked out here, which is most primary importance for our customers per se. And if you can just categorize as for the product, if this is the product characteristics, if we look into it, this is the product characteristics, and we find the relationship has been said whether we meet them or we do not meet them. So if we look out here, we will understand how good or how well we are deploying the quality functions, how well we are being sensitive to the customer requirement, how well are we excelling our positions time and again, as the case might be. So yes, this is the voice of the customers, being durable, being lightweighted, roomy, looking nice, being handy at the lowest possible cost. Remember, the weightage are separate and given in a different ratio, but total summation of the weightage should add to the 100% satisfaction of the customers. So that is what we've been looking into it. Now we're designing a product, keeping the customization, customer expectation in mind, and how much do we meet? We might not be able to meet it. Be very roomy, probably very nice looking, very slick looking, very low costly. But some of the features definitely we can make. We can make it roomy or probably low cost or probably durable. You see, there is a mix and match that comes around it. And then comes the customer based benchmark. Well will the customer lap it up? That is the main question that needs to be answered as on when on basis. Yeah. So the voice of the engineers is what we are looking for it. There are certain parameters that we cannot breach. There are certain things that we need to adhere to. So QFD, the house of quality, as the case might be, adding trade-offs, targets, developing product specification. What are the trade-offs? Yeah, are we making it roomy? Then probably cost might be compromised. Are we making it friendly looking, or are we making it low cost? Probably we are not able to come at and compromise on a weight category. It might be a little bit not so lightweighted, and so on and so forth. That comes around it. So technical benchmarks is what we should be striving for. Absolutely, yes. This is what The technical benchmark is all about it, but exactly what should be the target? Target would be the customer satisfaction, customer requirement. But you see the targets and the technical benchmark, there might be some disarray. They may not be completely in tandem with each other, and that is what the trade-off is all about it. So reliability is critical to quality. Reliability is the probability that a product, probably a service, or a part of the function will be expected to function. And please believe me or not, no product is 100% certain to function absolutely in a perfect way. Reliability is a probability functions dependent on some part, subparts, and component thereof. Now, what are the criticalities to quality? Now, we have a reliability of system, that is a product which is a component of a numerous product. So reliability of one product depends on the reliability of number of subproducts that is goes about it. Let's say RS is equal to R1 into R2, R3, R4, as this is been shown out here. So reliability of product or system, and R1 is the reliability of component, as the case might be. Similarly, for the critical to quality, can we increase the reliability by placing components more or less in parallel with each other's? Parallel components allow system to operate. If one of them falters, the other will pick it up. So this is what parallel component systems are there. So we have RS, the reliability of the system, R1 plus R2 multiples probability needed for the second component or second component per se. With this, we need to understand how do we manage supplier qualities. Not everything can be produced, not everything can be outsourced, not everything can be predicted as per the requirement. So there is something which we need to understand probably. Quality products becomes a quality source issue. This is what needs to be done as on when on basis. So let us face the quality, total quality extensions about the quality of the products from the company suppliers. If we can take it up as an issue at the supplier point of view, we will have a better finished product, which is going to probably surprise the customers and make the customers a wonderful experience altogether. The wow moment will be created. So yes, quality products come from quality sources. Quality must be built into the process. Quality at the source is believed to be better than to uncover some quality problems later on. Total quality management extends to the quality of products of one company's suppliers also. With these words, I would love to sign off from this presentation. Thank you once again for watching this video.